what's an indicator? We are going to do through indicator-based risk. So the first question is, what's an indicator? This is one of the multiple definitions that you can find. This is the Cambridge Dictionary. This is economics, finance, but there are some other definition here. Something that shows what a situation is like.
Yeah.
Okay.
Makes sense. Okay.
Cool.
A device that shows a value or a change in level. A device. Okay, we can draw a device.
What is a device?
Now we have a device. No. This can be a starting point, and maybe this should be the starting point.
A circle?
We'll see. No,
Device.
not a circle, but a
Device.
Low, medium.
okay.
It's like a gauge.
I see.
Oh, okay.
A sign or sign thing or signal that shows something exists or is true, but that
Yeah.
makes something clear.
So it could be like a light.
Yeah, make something clear. Yeah, something that shows what a situation is like or how it's changing. Yeah, it makes sense. Those are the more. Okay.
Percentage.
So we are going to base our risk analysis on indicators that are something that help us to understand better the thing that we are want to represent. In this case, the risk. Okay, but the problem is that something. What's something? I have had more than 2 students that have fallen doing that.
Look at this stuff.
Yeah, and one finished in the hospital.
Oh my.
I had that balance for so long. That was crazy.
You are not the first doing that in class. But for the multiple students that have done that, 2 ended in the floor and 1 in the hospital. So,
Sounds like they were bad at it.
so what's something we want to create? So the first thing that maybe we need to think on is what type of indicator we want to create and to use for our risk. Because that is going to define a multiple questions that are going to appear during the process. So what something do you want to create?
An index.
Probability
index.
of flooding.
An index. Okay. And what are the results of your index? A number,
Yeah.
a grading with letters, a grading with colors.
Colors.
I don't mind.
But the
Symbols?
the grading- But I have a question.
Yeah.
Aren't the symbols and the colors and the grading, isn't that based on a number?
It can be.
Can it
How
not
can
be?
it not be?
And that's the best practice, is to base your indicators on what they represent. A device that shows a change in something, and the other situation, like, I don't know if there was another definition talking about something, the situation. What we are going to do is to base our indicators on existing data. Okay, we are not just defining the value of the indicator by our perception. We will do that because that's perception-based risk analysis.
Okay.
Okay, but at this level, we have some data, so we are going to have to base our analysis on existing data. But the point is not the color or the letters or the symbols or the numbers, but the number of scales that you want to use. I'm going to define my risk in 3 levels. Okay, I'm going to define it in 5, in 100, because I'm going to measure by an index from 1 to 100. Okay, but we need to start thinking on the indicator, on the something that we are going to use to represent our risk. Okay? You are going to ask anything?
No.
Okay. So,
Well, don't we also think who is the indicator for? Does it matter?
who?
No. Whom? Like, who is receiving the indicator?
Yeah,
Like, are we giving
yeah,
a report to
yeah, of course,
policymakers? Are
of
we giving
course.
it to the public?
Of
Because
course.
I can say like from 1 to 100 is gonna be very confusing for people to say like, are we at risk or not?
Or not, or maybe it's easier to understand. I don't know, but of course,
It matters.
okay? So now, we have our risk indicators. And now, we have our hazard indicator, our exposure indicator, and our vulnerability indicator. Imagine that we are going to work 1 to 100. Okay? So our risk is going to be expressed in a number from 1 to 100. Are you going to use the same scale for the hazard, exposure, and the vulnerability or not?
It depends on how I relate the risk to the hazard exposure. So if I have like an equation for that.
So, 2 questions. First, what are you going to use here? And second, how are you going to transform this scale and this scale and this into this one? So, how are you going to aggregate? Options.
We can add each value.
You can sum.
Yeah.
If it multiply, maybe better.
Yeah, probably multiply.
If they're all like probabilities.
Well, it has a good vulnerability applied, but
And
exposure
multiply
applied.
it.
Yeah, so
Yeah.
We can do a weighted sum, like each one has a.
Weighted sum, what do you mean?
We give, one of them is more important depending on the grade. Like if it's between this range, it's this important. Like it's almost negligible. But if it's between this range, it's more important because now it's something.
Sounds like that's multiplying the hazard.
Or like
What I understand with weighted is that, okay, I have, let's say, 1 to 1.
and I average
Okay.
with weights.
And I can sum them. And I say, I'm going to place a weight of 0.5 to the hazard, 0.25 and 0.25. That's what I understand for weighted.
Yeah, that's kind of what I meant.
Okay,
Uh,
you can do that.
What's the difference between?
But what's the rationale of considering that the hazard is more relevant than the exposure and the vulnerability? You can justify that, don't worry. Everything can be justified. But there should be a reason why you consider that the hazard should be account for double that the exposure and vulnerability.
Yeah. Well, sum doesn't really make a whole lot of sense, right? Because if your vulnerability is 0 and you sum, you're gonna get a non-zero thing when you're actually not at all vulnerable. So like, there's really no way you can coerce this to be a sum problem, right?
So consider that you are exposed. You live in a really valley, in a really low area. Okay, your house is a hut made with the worst materials in the world.
Hut.
But you are in the desert. So your risk is going to be 100 and 100, 200 over 300. You are at risk. You are never at risk in the desert of extreme precipitation. That's the problem with the sun. Okay? But you can use the sun.
You can.
You can do whatever you want. Everything has pros and cons. Okay? The average. The average is a sum.
Yeah.
But it's yeah.
So kind of funny.
But then it would be like a weight, but I was gonna say
For me, it has more sense the average than the sum. Because if you have here 0, you are going to like lower the result. Maybe the best approach is then to multiply. But
doesn't it make sense for some of the indicators to try to approach it as not a single variable thing? Because we were thinking about, for example, it is not the same if it rains a lot over time in a low level area than if it rains a lot over time in a pretty evenly leveled area. So kind of like the hazard is composed by these two variables, for example. It's not only the rain over time.
I will
it's
go there.
the level.
I will go there. Okay? So, first question was to define how to aggregate. Depending on this, you will need or not to normalize. Because if you are using the 100 and you multiply, and you want to express it in 1 to 100, maybe you obtain 10,000, 1 million. So, 2 steps. How to aggregate, and you need to decide if you are going to normalize to express in what you really want to express. Remember that you can use other levels here. So, if you are using other levels there, maybe you can sum. Imagine that we are working with low, medium, and high. You can do that.
Then what's low plus low?
Just define it.
So you have no exposure, and then you add in your hazard, and now you have medium.
Low, 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 0. Low, low, medium, 10 or 15. I don't know. I would say that the different.
It kind of skirts the problem of like low being 0 for one of them still though, right? Like there's no way to have hazard if the probability of a hazard is 0.
What I want you to understand is that you have
Yeah.
lot of possibilities, and I just want you to think on the multiple possibilities and the multiple combinations and how to address. Obviously, it's not the most common to have the hazard, exposure, and the vulnerability in low, medium, high, and then you want to spread the risk in 1 to 100. Not makes sense, but you can.
Yeah.
I will never do that, but you can.
Like my point was
Okay?
if you're
It's not common,
and there's no way.
It's the other
the
way.
other.
The other way.
You have this 1 to 100, and at the end,
Non-zero.
It's slowly
because you
to
want to communicate a better or simpler way, you express them in 3 levels. But everything can be done. And now, the hazard. How do you obtain the indicator for the hazard?
index.
And you say, okay, I have multiple variables. Precipitation. And someone has asked, the precipitation that we have given us, what is? And I have said, what do you want? The mean, the annual mean, the daily mean, the total annual, the extreme return period of 10 years or 100, or what do you want? That is, you have. Let's say we have annual mean, return period 100. What are other hazard indicators do you want to use, or variables do you want to use? The elevation. Wave height for extreme precipitation?
Yeah. Drainage.
Sorry?
Drainage.
Land cover.
Drainage. That's exposure vulnerability of hazard.
Well, it's also part of hazard because
That's maybe
if it rained yesterday and there's still flooding from yesterday, and then it rains tomorrow, your hazard's actually higher than if it just rained today.
But
But
it is
it's-
exposure
it
though.
is because
Or
of
vulnerability.
exposure.
It's
maybe that's
vulnerability.
a box that we don't want to open now.
Okay.
That's a causes of keep it in the maybe it's
I think that's more sure.
I think it's
more
vulnerability,
vulnerability
yeah.
than
Yeah.
It's
Because it's related to the area and not how much rains.
it's really how much it rained yesterday though too. So
No.
there's also the hazard from yesterday. Because if there's 2 storms back to
But-
back,
Yeah,
there's
but
a
if
higher
you have
hazard than
But
if
the
there was
drainage,
just a
Because
storm
of
the
yesterday.
drainage specifically, it depends on where you are.
So
It
there's
doesn't
elevation.
depend on. True. Yeah. We could also argue that elevation is just like drainage.
Yeah,
Yeah.
yeah, I see the point. I completely see the point.
Yeah.
So basically,
I agree with you.
Yeah. the categories
everything
are
is
kind of
wrong
fluid.
and everything is right at the same time.
But I have placed it in hazard because I see the point that
the drain.
You can.
You can make it better.
let's say the case, the example that I have
We can change
talked
it.
with him regarding this. Okay, I have a house.
For the hazard, yeah. These are things that go into the hazard indicators, not the indicators
Okay,
themselves.
I have a house. The exposure is the value of the house is
And
itself.
then the other data that we're talking about,
The house.
that's like, yeah.
That's the exposure. Okay. The vulnerability is how the house is made. It's made of
Straw.
wood. Okay. So it has a vulnerability to flooding. Okay. Okay. And now my risk is higher. So this is the same house. Okay. My risk is higher if my house is in the top of the mountain or in the bottom of a valley. My risk is higher here, okay? But the house is the same. The exposure is the same, the vulnerability is the same. So the elevation maybe goes for the hazard.
But when we're talking about the drainage, we didn't mean like the drainage system.
No,
It's
I'm not
just
talking
like-
about the drainage, I'm talking about the elevation.
Oh yeah, but I'm just kind of walking through the same process. And if we're talking just about, for example, the land, So how much of the water
But
percolates in the...
for me, maybe the drainage is more related to the house. The house has drainage or not?
But also your land has drainage,
Well,
like based on the
yeah,
elevation.
like how much water goes into the ground. That's what we meant.
Okay.
Yeah, like the persistent. Does like is there a persistent state of like damage after a storm that like propagates forward for the next storm?
Because if you're like in a sandy area...
Yeah, no, I see your point.
Yeah. Yeah.
Why not? Why not? I mean, that
Yeah.
the philosophical question is there. We can take 60 hours of course talking about that.
Yeah.
So, imagine. Let's leave the drainage for later. We have any other indicator or any other variable for the hazard indicator? We accept that we can have those three. Okay. So we have the annual mean, we have the return period thing, and we have the average elevation.
But you just said elevation doesn't affect the hazard. So
No, I have said the elevation affect the hazard.
you just gave the example that.
Yeah, and in my example I said
Okay.
the house is the same, so the exposure and the vulnerability are the same in the valley and the mountain.
Yeah.
So the elevation can only affect
Okay.
the hazard
Yeah. No.
because the risk is different, so it should affect anywhere.
Right.
Okay?
Okay. Yes. Thank you.
So, how can I transform these figures? Average elevation 30 meters, return period 11, 100, 1,500 millimeters, an annual precipitation, annual mean daily, 35.
Yeah, that's what I was asking for.
Final step.
Something's already done.
I'm going to have one indicator here, again, based on the scale that you want. One indicator here, and one indicator here. Okay? I will need to aggregate them. I don't know how. Maybe I will need to normalize them. Okay? But how can I transform this number into this indicator?
Legend.
That's our final step. We have everything here, more or less. We have what we want to obtain. We have said, okay, I'm going to make the measure based on this, the same for the hazard, exposure, and vulnerability. I'm going to aggregate them. You know how. I'm going to normalize. For the hazard, I have 3 indicators that I'm going to aggregate them into this, because here the return period has different weight because it's more relevant than the annual mean. So here it makes more sense to have different weights for the different indicators. Okay, and I'm going to aggregate this way, and I'm going to normalize to have the 100. Agree. Everything's clear. Final step. How can I transform this number into sorry?
You say, I don't know, for example, if it's, because you only have one number. Because I was thinking if you have elevation from 10 to 20, you say it's medium.
Okay, so that's one case. We can apply the indicator risk space for one single range. Or to multiple locations. I told you last week, I don't know if I repeat it today. We are analyzing all the municipalities in Cantabria. So imagine that we have all this data for all the municipalities. So you have 103 elevations.
There's no point in sending it to you. It says you.
Wait, so it's a mean elevation for the
So
entire
we have
municipality?
a sample that goes from
I think. But we're
0
gonna
to
have-
5
Yeah, we're gonna
to
essentially have municipalities. So you can have like a Z score of
and here you have 103 values. So now you can do what you have told me, that is okay. I'm going to take the mean, I'm going to take the maximum, and I'm going to take 5 levels. Okay, 5 levels. 1, 2, 3, 4, 5. Okay, that's a 5. Or minimum is 1, maximum is 100, so that is. Or I'm going to make the distribution of this, so I'm going to take percentiles. Or say now, I am an expert, so I know that if the okay, not for extreme precipitation, but for coastal flooding. For coastal flooding, I know that I'm not going to have coastal flooding with more than 10 meters elevation. So I go here and say 10 meters. This is 50. And here, from 0 to 1 to 10, I define the different intervals.
Why would I have indicators for the variables that are inside the hazard instead of having one indicator in the hazard that takes into consideration all of them? Why would I need an extra indicator for each one of them?
Okay. Do you want to obtain the indicator for the hazard?
Yeah.
Okay. And you have these numbers.
Yeah.
How do you obtain the indicator?
With an equation that relates them.
The equation's implicitly mapped.
Okay. Lucky you. No, not lucky you. Good luck.
Alright.
I mean, completely possible. Completely. Okay? So, you are saying that my hazard indicator is going to be, let's say, a polynomial. A coefficient times the elevation plus another one for annual precipitation times plus the tier 100 precipitation. Perfect. How are you going to calibrate those parameters?
Yeah, okay. But what if,
You can do that.
but my
I
question is,
would be really love if you next year you need to select your master thesis and you say, I'm going to make an indicator based on mobile risk analysis based on this type of approach. Count on that. It will be on your plan. Don't worry.
but my question is, I also have to relate them whether they are numbers or whether they are other indicators. So if I have a scale with the elevations, I still have to somehow define how that scale is affecting my hazard and by how much. And so that's kind of the same thing as saying, okay, this number times this number. Does that make sense?
No.
So how do I do with the other one?
Yeah, you have to kind of assume some mapping one way or the other.
I don't know if
I'm not sure either.
because so if I have an indicator for the elevation and one for the return period
Yeah.
and one for the annual mean,
If you have an indicator for this, then you are obtaining this. But
Yeah.
this is expressed in the levels that you want. Let's say 100.
yes.
But that means what you actually did isn't just add a coefficient. You're doing h of f of
This is
elevation,
a weighted
h
sum.
of g of.
This is a weighted sum. This is a weighted sum.
Yeah. But like the actual to 100, like means
But
you're
the question
applying
is,
some
do
non-weighted
you want to transform this into this 100 or not?
Yeah.
That's a step that you want. You need to think if you want to take or not.
Yes.
If you do, this is simple.
Okay.
If you don't, these coefficients will be hard to obtain. Because those you want to represent. You want to represent that this number increases hazard as it increases or as it decreases. So, if you want to directly introduce the value of the variable in your hazard index calculation, this coefficient or this expression needs to account for that. If you take the previous step and you transform this value into a measure 100 high, medium, low that express the contribution to the hazard, then this aggregation is simple. But I don't mind if you do it as a next step and then you add, than if you just want to compute a single equation that accounts for everything. In coastal flooding, in fact, I'm thinking, I'm not sure the elevation represents anything for extreme precipitation, but don't worry. For coastal flooding, okay? Imagine that now we have coastal flooding. I'm going to delete everything. And now we have wave height, period, and elevation. Okay? The higher this is, the higher the hazard. The higher this is, the higher the hazard. The higher this is, the lower it is. So, you can transform this in single steps into indicators, or you can create the mega equation that does it automatically. I don't mind. But you at the end you need to make the same steps.
Yeah, I understand. So if I have them separately, then I would much rather make them into the same like 1 to 100 scale and then have a factor for them. But if I know that there's somehow a mathematical relation between them, then I could possibly just use them in one equation to have the indicator for that.
Yeah. It depends. It also depends on how you transform these into indicators. Because I have said you can take the minimum and the max of the sample.
Yeah.
In Cantabria, for extreme precipitation, you have 103 values. Imagine that you are analyzing all the municipalities in Spain. You have 10,000 values. But in other cases, you don't want a sample because you are going to use your express criteria. And you are going to say, elevation, 0 to 10. I don't mind the data that I have. This is going to go from 0 to 10. But it depends on the method. these are some of the processing methods that you have to obtain for indicators. This table is in the slides that you have on Moodle. Right? This is from the document from Esprit. And here you have the minimum and the maximum. The minimum and the maximum, but with custom ranges. I am an expert and I know. Probability based on the distribution. Just to rank. I have 100 values, so I'm going to rank them from 1 to 100. So this is more at risk than this other. Even maybe they are all with a average elevation more than 10, but you use that method and you obtain the value for the indicator. The flag, I don't know what's flag. I will take a look. This stands to our reference. How near they are the 10 meters threshold or raw data, whatever. So each of these decisions in the whole process has multiple consequences, positives and negatives. So there is no a single and the unique methodology to follow to obtain this. And that's why I have wanted you to think on all the process, because the combinations are things. So you just need to know that to do this type of analysis you need to take decisions, and that your decisions will imply some consequences on the final result.
Yeah. So when you're doing the indicators, like you're saying like the coefficients for the equation, it's like kind of audacious to assume you have these like coefficients that give you this relationship. But when you're doing these indicators, aren't you kind of implicitly assuming some relation between these to say, oh, to map these to the same scale, you're then having coefficient 1, but the map itself is like a function that's more complex than the coefficient. So you're already imposing a relationship between these without any real empirical reason to.
Yes.
Yeah, like they seem kind of the same, right?
This is I have told you. I have told her. It's the same.
Yeah. Okay.
If you want to create a single equation that solves all the different things that you need to do here to obtain the indicator, that's fine. But for me, it's more complex.
Yeah.
Because if you want to make it more complicated, I have said here 0 to 10. Why? Because I know that the hazard value. In this one, I'm going to use the rank, and in this one, I'm going to use the minimum and the maximum. You don't need to use the same method for obtaining the indicator for each of the variables.
Right. But it's not at all clear that after doing those relate in the way that you want.
Sorry?
It's not like at all clear that after scaling those the way you want, that like the relationship between those is now like hazard in some like easily decoupleable way, like that you add them or multiply them and that's like the appropriate hazard.
I'm not sure I understand the question.
Like, you made these indicators.
I transform these values into an indicator.
Right. I guess what I'm saying is the relationship between the indicators and the relationship between the raw variables, like it's not any more clear that the relationship between the indicators is less complex than the relationship between the raw variables.
The relation between these to obtain this is quite simple.
Maybe.
Or not.
Maybe.
I mean, we have the same problem here. You can multiply them, you can aggregate them.
Right. But for them
But
to actually be simple,
for me, the complex step is how to transform this variable into this indicator. For me, because aggregating indicators is quite easy.
right. I guess it's just not at all
Even if you
clear.
are summing, multiplying, going for the average or whatever. But the problem is how you transform the variable itself into the indicator.
Yeah. Okay.
sum.
Staple stuff backwards. The packet you gave me and this are like stapled backwards.
Like, it's not like I'm just reading that like and then max so that a straight like
Is it just I saw your screen and I saw like the tricky thing came up?
like just because they're on the same scale now. So you're going
Yeah.
Okay.
You would do much. How would you write an equation that gives you? How would you define?
What do you have here?
Combine HST or
The second page, you have some